All right, there we go. So before we even start section 6, I want you guys to see what these graphs are going to look like. So let's just put in right here, y equals 1 over x. So y equals 1 over x. This is what our graphs are going to look like, which is rather strange looking. So let's talk about some of the important pieces of this. Does everybody see that our graph does something strange at 0? Yeah. Like the graph's going along and then it drops all of a sudden and disappears and then restarts back up here and keeps going. Why? What's special about 0? What happens when x equals 0 to the equation or to the graph?
It's in the middle.
So it is in the middle. What about that? It's equal to 0, but why is that special for this? What happens if I actually put in, so everybody, I can't divide by 0. And so if I put 0 in here, 1, and I know it's several of you started to say that, 1 over 0 doesn't work. That gives me an error. And so that's why the graph just breaks there. There is no graph at 0 because that's where I would be dividing by 0. And again, everybody's full attention. Earbuds out, put everything else away. Make sure you guys are focused. So a couple other things then. That's an asymptote. We don't have a value. We don't have a graph at x equals 0. An asymptote is a line that we don't cross. And so there's going to be a line at x equals 0 here that we do not cross. Similarly, okay, everybody, if I start plugging in bigger numbers, 1 divided by 1, if I just put 1 in, 1 over 1 is 1, 1 over 2 is 1/2, 1 over 3 is 1/3, 1 over 4 is 1/4. It's getting smaller and smaller. Am I ever going to get to 0? Now, if I'm taking 1 and dividing it by stuff, I'm always still going to have something. Does that make sense? So there's actually another asymptote right here at y equals 0, going right along the x-axis. Because no matter what I put in, I can put in bigger and bigger numbers, but I'm never going to actually get out 0 from this function. I can't put 0 in, and I can't get 0 out. So I have 2 asymptotes, a vertical one and a horizontal one. And again, if we kind of look at that, x equals 0, there's my vertical asymptote. If I put in y equals 0, there's my horizontal asymptote. This graph never crosses those lines. That is what we're going to use to graph this, that feature of these graphs. So let's go ahead then. And one other thing, you guys, grab a calculator. You can use your phone, use a basic calculator. Let's look at what happens to the graph as it gets closer to 0. Put in 1 divided by 0.5. What's 1 divided by 0.5? 2.
Wait, what am I dividing by?
If you do 1 divided by 0.5, you get 2. What's 1 divided by 0.1?
1. I guess that's right.
It's 10. What's 1 divided by 0.01? 1 divided by 0.01. It's 100. And the reason for that is, remember that when I divide by a fraction, I multiply by its reciprocal. 0.01 is 100th, 1 over 100. So if I do 1 divided by 100th, that's the same as doing 1 times 100. The smaller the number that I divide by, the bigger my answer. And that's why this graph just blows up and goes up to infinity as it gets closer and closer to 0. Does that make sense? I'm dividing by smaller and smaller numbers. The answers that I'm getting out get bigger and bigger. So let's take a look here. Thank you. So everybody, look over at the... Go ahead and, let's see if I can get it to switch. There we go. Look over at the notes now. There's the notes. So on the notes, you're going to see an equation that has h and k, the same h and k that we've been using every single time we've graphed. And they do the exact same thing. So right here, this h value is going to be our shifting left and right. So h shifts us left or right. And it's also going to be our vertical asymptote. It's going to be the number that I can't plug in for x. So here, x is equal to h is my vertical asymptote. X equals h is our vertical asymptote, whereas the k value is going to shift us up and down. And y equals k is going to be our horizontal asymptote. So we're going to start with the most basic, the one I just showed you on Desmos. If I filled out a table with values, so I plug in -3, 1 over -3, 1 over -2, 1 over -1. I plug in -3, I get out -1/3. I plug in -2, I get out -1/2. I plug in -1, I get out -1. And we see a little bit of that curve right there. But when I try to plug in 0, I get an error. You can write error, you can write does not exist. You can write a little dash. The idea is that there is no point at 0 because that would make me divide by 0. So now, if I plug in 1 over 1, well, that's just 1. Plug in 2, I get 1/2. Plug in 3, I get 1/3, and it's dropping down again. Now, this would be even better. This graph would be even better if I had plugged in like 0.5, like we did before. Remember, we tried 0.5, we got out 2. If I plug in -0.5, I'd get out -2. And now we can really see that curve shape starting to show up. Because this graph doesn't have an h or a k, both of them are 0. So the h value, x equals 0, is an asymptote. Let's use a different color here. So here's x equals 0. Here's y equals 0. I cannot cross those lines. And so now, if I draw in my graph, I'm going to go right along those lines and through those points. Go right along the asymptotes, so get as close as you can. And make that curve. Now, this is actually a fancier graph, a more exact graph than I'm going to expect from you. For the homework, I literally just need 2 points, one on the left and one on the right of the vertical asymptote. As long as you get 1 point on the left of the vertical asymptote and one on the right of the vertical asymptote, that will be enough to make sure that you're graphing in the right spot. So now let's talk about these questions. They've got all these questions of describing the graph. The domain. This graph covers all the x values except for the asymptote. So the domain will always be -∞ to h and h to infinity. So I'm going to write this as -∞ to 0 and 0 to infinity. That is my domain for this graph. My range is going to be everything except for the k value. -∞ to k, k to infinity. So in this case, again, k was also 0, so negative infinity to 0, 0 to infinity. Does that make sense? Yes, just be quick, okay? You may have to go upstairs. It was locked earlier. So go ahead. There we go. So now, does this graph have an x-intercept? How can I be 100% sure this graph does not have an x-intercept?
They don't touch.
It doesn't touch because it's the word that you're looking for, I think. So that, is everybody good with the idea that the asymptote, I have an asymptote on the x-axis. And if I have an asymptote on the x-axis, I never touch the x-axis. Don't touch the x-axis, no x-intercept. Does that make sense? So in this case, none for the x-intercept, and we have the exact same problem for the y-intercept. None, because the asymptote is on the y-axis. That will not always be the case. Now, we actually already did this. Go ahead. We already did the asymptotes. The asymptotes are y equals 0 and x equals 0. The x one, x is the vertical one, y is the horizontal. So let's do a slightly more interesting graph here. Let's do number 2, 1 over x plus 2. Focus. So right here, there is no h value again. Does that make sense to everybody? No h value means a horizontal asymptote at 0. Nope, that was not right. No h value means a vertical asymptote at 0. It is important that you get those correct and not switch them. Your graph's going to be wrong and it's not going to work out nicely. So the horizontal asymptote is 2. So right here. There's my horizontal asymptote. Now that I've got those two, I am going to plug in a point on either side. Okay, last period, I don't know what it was. I gave these instructions and we had some issues. I got asked the same question like 10 times. I'm going to pick 2 points. I'm going to pick one to the left of the vertical asymptote and one to the right of the vertical asymptote. That is how you pick your points. And the vertical asymptote, go one to the left, go one to the right. So in this case, if my vertical asymptote is 0, I'm going to plug in -1 and +1. So I'm just going to go over here, f of, choose a different color again, f of -1, 1 over -1 plus 2, -1 plus 2 is +1. So I plugged in -1, I got a +1, that's this point right here. Then let's plug in +1, that would be on the other side. F of 1, 1 over 1 plus 2, 1 plus 2 is 3. Right there. Does that make sense to everybody? And again, I picked those points because there's one to the left of the vertical asymptote and one to the right of the vertical asymptote. Once you've got those points and the asymptotes, here's how I want you to graph. Go to that point and just sketch along the asymptote. Make a nice little curve and then same direction, following right next to the other asymptote without crossing it, make that curve. Does that make sense to everybody? That's all I need for that half. And then the other half, same idea. Start at that one point that you got. Go next to the asymptote here without crossing it and curve around right next to the other asymptote without touching it. There is our graph. That would be 100% full credit for that graph. It's got the 2 asymptotes It's got 2 points. It curves the correct direction and it doesn't cross the asymptotes. Does that make sense? I'll show you another example in a little bit, but now that we've got that graph, now that we've got the graph, let's go over some of these questions. Domain and range. The domain is everything except for the h value. H value is 0, so the domain here is negative infinity to 0, 0 to infinity. The range is everything except for the k value, so negative infinity to 2, and then 2 to infinity. X-intercepts. Does everybody see that this graph does have an x-intercept? It does cross the x-axis right here. The problem is that that's not a whole number, and I don't know what it is. So to find that, if you ever need to find the x-intercept, it's always the same. You make y 0. So that means I'm going to say 0 equals 1 over x plus 2. To solve this, I'm going to subtract 2 from both sides. So minus 2, get negative 2 equals 1 over x. And then you could even make this a fraction and just cross multiply. Negative 2x equals 1. Divide by negative 2. And we get x is equal to negative 1/2, or an x-intercept of negative 0.5, comma 0 would be fine. Negative 0.5, comma 0, which looks right. If I look at my graph, it looks like it's crossing right about negative 0.5. So if you want the y-intercept, or sorry, the x-intercept, plug in 0 for y. Does that make sense?
Yes. Let's see here. Where did they put? I gave it to this stuff. Yeah. See your name. So I will get it to you later. It looks like, I don't know where they put it. Don't worry about it. I'll do it. You can go if you want. Yeah, go ahead. Yeah, well, okay. Go ahead then, and if you can wait just a minute, then Michaela, until she's back. So, sorry about the pause there. Does this graph have a y-intercept? No, it's got the asymptote on the y-axis. No y-intercept. So put none. We already did D. I should have written it down right when we did those. We have a a vertical asymptote. The vertical asymptote at x equals 0. Whereas the horizontal asymptote, why is this not working? There we go. Would be at y equals 2. And Michaela, you can go. Someone just go back. So I would say again, write down those asymptotes as the very first thing you do on these problems. Now it says state the interval on which the graph is increasing or decreasing, increasing and decreasing. These graphs always do one or the other. They're either all increasing or all decreasing. So if I look at this graph, then you see that if I start at the left, it's going along and then it drops. It's going down that whole way. And then it breaks and starts over again at like infinity and then goes down from there. The whole time it is decreasing. It's going along and going down from left to right, breaks, starts over, goes down from left to right. That means that this graph is never increasing. Increasing, put none. Decreasing, put the whole domain, negative infinity to 0, 0 to infinity. And then the last piece here, state the interval on which the graph of f is greater than 0, and state the interval on the graph of f, or on which the graph of f is less than 0. If it's greater than 0, it's above the x-axis. If it's less than 0, it's below the x-axis. So looking at this graph, this piece here and this piece here are both above the x-axis. They're both above 0. Is that making sense to everyone? I see several of you that are getting distracted. Again, don't have your phones out. Don't do other stuff that's going to distract you guys. I know that graphing is not our favorite, but that's all the more reason to give me your full attention to make sure it's as easy as it can be, okay? So those two pieces are both greater than 0. So I'm going to say that this graph is greater than 0 from negative infinity to this point right here. What's the name of that point? What do we call that point where it goes from above the x-axis to below the x-axis? We already found it. Not quite. This point, I had circled it before. Everybody sees the point that's circled right there? We already found it. We wrote it as one of our other answers. It's the x-intercept. I heard a couple of you say it. Does that make sense to everybody? That's the x-intercept. That's where it goes through the x-axis. So it's going above the x-axis from negative infinity to the x-intercept, negative 0.5. And then it's below until it gets to the asymptote. And then it starts above again from 0. And the whole rest of the time it stays above. So when they ask me, where is it below the x-axis? Well, that's just this piece right here. That piece is below the x-axis, and it's essentially the rest of the graph from negative 0.5 to 0. The x-intercept to the asymptote. So I have three pieces of the graph. It starts off above, then goes below, and then it's above again. Let's do one more, and then I'm going to have you guys try this. So number 3, this is as hard as it's going to get, and this is the one I'm going to have you try in just a minute, one very much like this on the homework. So here we go. Everybody's full attention here. The very first thing you have to do on number 3 is actually put together, you have to put together the equation because it wants g of f of x. So I'm going to start with g of x. So g of x here, 1 over x minus 2. So 1 over something minus 2, but where the x was, they want me to put f of x, which is x plus 3. There's g of f of x, which is what they told me h of x was going to be. So I've written out my equation. The very first thing you do is you find those asymptotes, which in this case is letter D on the notes. So state the equation. The equation of the asymptote here, x plus 3. X plus 3 means an asymptote at x equals negative 3, because that's what would make me divide by 0. That is my h value, negative 3. So the vertical asymptote is x equals negative 3. And the horizontal asymptote is just my k value, negative 2 right there. So the horizontal careful, don't switch it. X equals negative, or sorry, not x equals either. Back up. Y equals negative 2. Right? The horizontal asymptote is always y equals, and it's just whatever the k value is. Don't switch it, don't do anything. Just whatever that is, that's your answer. So now I'm going to graph those. Here's negative 2. Here's negative 3. Now, which 2 points should I plug in? Yes, that's fine. Which 2 points should I plug in here?
-2,
-2 is fine.
-3,
-3 is not fine.
positive,
-3 or +3 would work, but you'd get a really bad decimal.
1.
So how do you always find those 2 points?
I don't know.
What do you look at?
We play-
But there's one specific thing. This is the one that I said we had so many troubles with it last period. And I want to make sure you guys understand. What's the vertical asymptote?
3, negative.
-3. What's one to the left of -3? -4. Plug in -4. What's one to the right of -3? -2. Those are the 2 points you should plug in. One to the left of the vertical asymptote and one to the right of the vertical asymptote. So I'm going to come over here in the empty space and I'm going to plug in h of, actually, let's use a different color here. Let's do h of -4. So that means 1 over -4 plus 3 minus 2. That would be 1 over -1 minus 2, which would just be -1 minus 2 or -3. I plugged in -4. I got out -3, this point right there. Now I'm going to plug in -2 on the other side of the asymptote. 1 over -2 plus 3 minus 2. -2 plus 3 is 1. So 1 over 1 minus 2. 1 minus 2 is -1. So I plugged in -2. I got out -1. That is what I want to see. 1 point on the left and 1 point on the right. Preferably as close to that asymptote as we can get. So now my sketch starts at those points and curves up like this, down like this. Again, getting as close to that asymptote as we can without crossing it, without ever curving away, always getting closer to the asymptote. Making that as smooth of a curve as we can. There's my graph. So now, state the domain and range. Domain is everything except for the vertical asymptote. So -∞ to -3. -3 to infinity. The range is everything besides the horizontal asymptote. So -∞ to -2.
-2.
Yep, -2 to positive infinity.
Thank you.
Okay, here's the hardest part. The x-intercept. Does this have an x-intercept?
No.
Does it cross the x-axis?
Yeah.
Then it has an x-intercept right here. There is an x-intercept. I just don't know what it is yet. So to find that, I'm going to plug in 0 for y, and solve for x. So here, 0 equals 1 over x plus 3 minus 2. Add that 2 to both sides. So we get 2 is equal to 1 over x plus 3. You can make that 2 a fraction, 2 over 1. Cross multiply. 2 times x plus 3 is equal to 1. Yeah, if you need to. Do the distributive property. 2 times x is 2x. 2 times 3 is 6 equals 1. I can subtract that 6 from both sides. So 2x is -5. Divide by 2. And I get x is equal to -5/2. Or if you want to write it as a decimal, -2.50. That's the hardest part. That's the hardest part there. The y-intercept, no, that one is going to be, it's not going to be worth a ton of points, but it'll be worth 2. So
This whole problem will be worth 2.
that whole problem will be worth 2 points. Would you rather I make it worth more?
No.
Yes, we're trying to be nice. It's a hard problem. It's a hard problem. You need to be able to do it, but it's not going to be your entire grade. If you can get all the other pieces of this,
Yeah.
you'll still get a very good grade on this question if you do everything besides the x-intercept.
Wait.
The y-intercept, the x-intercept itself is worth 2 points. No, the whole problem will be worth like 10 points.
Oh my, that makes it even worse.
Okay. We're not done though. State the y-intercepts. This is easier. This is easier. We're just plugging in 0 for x. So y equals 1/0 plus 3 minus 2. 0 plus 3 is just 3, so 1/3 minus 2. You can do this on a calculator. You can do 1 divided by 3, get a decimal, subtract 2, that's fine. Or you could get a fraction, make this 2/2, make this 2 6/3, and get -5/3. So either -5/3 or -1.6 going on forever. Let's look and see if that makes sense. There's my y-intercept between -1 and -2. It should line up with your graph. So the last few pieces, state the intervals where the graph is increasing or decreasing. Turn to the person next to you. Tell me if this is increasing. Tell them if this is increasing or decreasing the whole time. It's one or the other. Is it increasing or decreasing?
Decreasing. Decrease.
So I'm hearing some confusion still. Everybody, if you want to be able to answer this question, which shouldn't be a hard question, let me have your full attention right now. Again, especially if you're having trouble with this, don't tune out. I am happy to answer questions and I'll try to make it as clear as possible. You always read graphs from left to right. So if I'm going along the purple graph here, can everybody tell that it's going down?
Yes.
And same thing, I start up here, it comes down. That means it's decreasing the whole time. It will be flipped upside down. We haven't seen one of those yet. There will be one. I'll probably show it to you on Thursday. So
Thursday. What's Thursday?
review. We're going to do the last bit.
Are we getting our test review that day?
So just a second. Let's go ahead and finish this one. This one is not increasing at all. If you need to, we've already got 3 people out. So if you need to, you can. But so increasing, none. The decreasing is the entire domain. It's not working. Decreasing is from -infinity to -3, and then -3 to infinity. Right. Where is the graph of f greater than 0? Well, just in this one little piece. This is the only piece of the graph that's above the x-axis. It's from the asymptote to the x-intercept. So -3 to, we said the x-intercept was -2.5. That's the one piece of the graph that's above the x-axis. Everything else is below. So if I look at the graph here, this piece is all below the x-axis, and so is this piece. Those 2 pieces, all below the x-axis, that's everything besides The one where it was greater than 0. So negative infinity to negative 3. And then negative 2.5 to infinity. Okay, let's knock out a few pieces of the homework real fast.
I say all of it. Knock it all out.
There's not enough time, but I can help you get at least some of it done.
Can we do?
So I'm going to get you started on the easiest ones first,
No, let's do the hard one.
and then I'm going to show you the hardest one. So stay with me, everybody. Look at numbers 5, 6, 7, and 8.
That just seems like, wait, what are you looking at?
5, 6, 7, and 8.
5 to 8,
Yep, 5 through 8.
right here at the top.
Yep. These you could do in like a minute for the whole, all 4 of them, because all you are doing is listing the vertical and horizontal asymptotes. So I'm going to do 8 for you right now. Number 8, the vertical asymptote. Vertical asymptote comes from right here. X equals positive 7, the opposite of what's there. That's my vertical asymptote. The horizontal asymptote comes from over here. It is not switched. It's just y equals negative 4. That's my horizontal asymptote. Ran out of room there.
So
That is
number
all you have to do for numbers 5, 6, and 7, and 8. If there isn't a number there, it's 0. So literally 1 minute, and you could probably finish 5, 6, and 7 right now. Go. If you're not sure, raise your hand and ask right. What was
Would it
that?
be a negative 1 if that X is positive?
If it's x plus 1 on the bottom, then it would be negative 1.
No, I'm saying for number 6. I mean,
So for number 6, it should be 0, because there's not a number there. As long as you label them as x and y, that's enough, because the x is always going to be the vertical one, and the y is always going to be the horizontal one.
okay, that's what I was actually letting it out.
Now, before you go,
So where?
we're almost done. Everybody look at number 3. Go back to the previous page. You go from the easiest ones to the hardest ones, and I want to give you a head start on this one. This is exactly like the one we did at the end of the notes.
Oh my.
You set up the equation with g of x. So 1 over something plus 1, and that something is f of x plus 3. Sorry, no, x minus 3, getting ahead of myself. X minus 3. Yes, you do. X minus 3. So that lets me find the vertical and horizontal asymptotes. The vertical asymptote is x equals 3, right? The opposite of that, guys, I'm going to let you go on time. I would really recommend you leave stuff out so you get this last little bit. I'm trying to help you out with this problem.
I'm ready to.
The horizontal asymptote, right here, y equals 1. Now, this has a little bit of an issue. Look closely at the graph. Each of those lines is not 1. Each of the lines is 2. So y equals 1 would be right here. X equals 3 would be right here. So what points am I plugging in? What points should I plug in to figure this out? to make the graph? 2 and 4. Does that make sense?
Yeah.
1 to the left, 1 to the right. Plug in 2 and 4. And more than likely, you'll get a point right here and a point right here, which you'll then be able to draw in your graph with and answer the rest of the questions. On Thursday, I'll be giving you a practice test. I'll be doing a couple more examples like this with you guys. The homework for this section is 1 through 8. 1 through 8.